Welcome to today's class. We'll be going through practical 7, which is operator overloading. So before I do that, right, before I get to practical 7, right, so let me just set up Notepad++. So let me say sudo nala install wine64. So I'm now using Ubuntu, right? So things are a bit different compared to Windows. So I'm just setting up an application that's gonna allow me to run Windows applications, but then the basic applications like Notepad++, since Notepad++ only comes in .exe form. So let me download Notepad++. Okay, it's almost done. At least my Wi-Fi is fast. So download the installer, done. And then, yeah, so there we go. So let me check how far it is. Okay, it's done. Now it's unpacking, setting up the packages. Okay, done. So now I think I can just say wine64 followed by the application name. So let me go to my downloads folder, list everything on my downloads folder. And then I want the Notepad++. So wine64 npp. Oh, it's wine. I think it's wine. Okay, yeah. So, okay, it doesn't want to. Okay, let me just do this. Open with other application. Come on. Okay, this thing is being stubborn. So let me say wine HQ download. And then, yeah, this is just something, this is just for me, right? On your side, you should have Notepad++. I just want to be able to use Notepad++. So Ubuntu, I'm using Ubuntu. So this is the first step. So copy that, then clear, and then make note of your distribution name. Ubuntu, blah, blah, blah. Yeah, I know my distribution name. And then download and add the repository key. No problem. Okay, done. And then I'm using Noble. So I'm running Noble version. But just to be sure, I could just say check the version, but then I'm sure it's Noble. Yeah, it's Noble. Yeah, I'm running Noble. Okay, before I continue doing that, let me say sudo update or sudo nala update, sudo nala update to update the changes that I've made. Perfect. And then clear my terminal. And then I'm gonna go and download. So now let me copy this. Copy, go back, and then Control Shift V. I think everything should be fine now. Okay, sudo apt update. I'm using Nala, which is a bit better than apt. So I'm just gonna say sudo Nala update, right? And then install the wine. So I want to install the stable branch. Hopefully I won't face any issues. If I face any issues, then I'll just use a different text editor. Yeah, I knew this would happen. So let me try installing that. Let me try running it again. So sudo nala install wine64. Okay, it's already there. How come it's not picking it up? It's supposed to be showing here. Mm, okay, so it's you say wine. Yeah, everything seems fine though. So let me say wine in. Okay, please execute. Oh, wine 32 is missing. Oh, that's why. So sudo nala install wine 32 i386. Okay, that's quite a big file. So I was just missing these packages, the 32-bit version of wine, which is fine. So let's just give that a second. As you can see, my Wi-Fi is like around 4 megabytes per second. 4 megabits, my bad. So 4 megabits bits per second. You measure the internet speed in terms of bits, not bytes. Um, okay, so while we wait for that, mm, okay, so what? Okay, it's almost done. Let's just wait for it. But then the practical, I would say that the practical is not too bad. The only things that are a bit tricky is this. You see the double indexing operator. That's the one that's going to be a bit tricky. But then I'll show you how to do that because you actually you can't overload the double indexing operator directly. You have to actually, you can only what is this, overload a single indexing operator. Okay. Okay, it's almost done. I hope it works now. Okay, so clear and then sudo nala update. Okay, and then now I'm gonna try it one more time. Could not load Kernel32.ddl. Why does it do that? It was working this other time. Mm, let me just give me a second. I'm checking something here. Okay, it seems like it's acting up. It should be working. Seems like it's acting up. So I guess I'll just have to use a default text editor to run this. Let me. Okay, so let me just exit. Let me look for. Again, I think I can use gedit. Yeah, let me just use gedit. So okay, this is not going as planned. Let me look for. Let me search again. Text. Hmm. G. Should I use gedit or? Yeah, let me use gedit. I don't know why it's not zooming in though. Okay, let me say it should support C++ language, and then preferences, the editor, the font. Okay, so let me change it here. So let me increase the font to like 18, right? I think 18 should be fine. So let me see if it's going to highlight. Okay, it doesn't. Not highlighting is the same way Notepad++ would be highlighting, but then still fine. Let me see. Am I sharing my screen? Okay. Yeah, I am sharing. So what's the whole point of operator overloading? So with operator overloading, right, we basically saying that our objects can work with operators instead of always creating functions, right? We could just create a function and everything would be fine. The same way when we declare like an integer and say int num is equals to like 10, and then int, okay, let me just call this int a, and then int b is equals to 20. I can say int c is the sum of a plus b, right? I can use the addition operator, right? So the same way we can work with these operators with primitive types, we should also add that functionality for our objects. Because remember, when you create a class, right? When you create a class, all you're basically doing is you're defining a data type. That's another way of looking at it. You're actually creating a data type. So I'll just save this as notes, and then line ending. I'm gonna end with Windows because you guys are on Windows. Save it on downloads. And then, okay, I want to make it a txt file, so .txt, and then save. So, so the same way we were working with operators on normal types, right? Normal data types. We want to be able to work with those operators on our objects, right? That's what we're trying to do. So how do you achieve that? You achieve that by doing something that we call overloading the operator. So when you're overloading the operator, basically saying that the object supports that operator, or the object can now work with, can be used in conjunction with that operator. What do I mean? So for example, if I have uj image like this, and then obj1 for object one, and then uj image obj2, I can say obj image, maybe I'll call it sum, right? Obj sum for my object that stores the sum. And then I want to be able to say obj1 plus obj2. That's what we're trying to do. Just the same thing that we're able to do with primitive types or the built-in types like integers, shorts, double, all of those types. We want to be able to work with operators on our objects. So this is pretty much what you're trying to do. You need to overload the operator. So how do you overload an operator? So to overload an operator, there's simple syntax, right? To overload an operator, there's a simple syntax. You use the keyword operator, which is a reserved keyword, as you can see it's highlighted, and then followed by the operator. So the hash will represent that operator you're overloading, right? And then followed by parameters. And then you're going to have a return type, obviously. Return type, basically what the operator should return. What should return after you've used this operator? So there's two ways we can also implement the operators. So just remember that the hash symbol just means the operator to overload. So for example, plus plus, the assignment operator, the comparison operator, and so forth, right? So that's pretty much the syntax for every operator that you want to overload. So when it sees this keyword operator, even though it's a reserved keyword, that reserved keyword operator plus that hash or that operator, it actually becomes the name of that function. So what do I mean? So let's say, for example, you want to overload, let's say you want to overload the plus operator, right? The plus operator. Oh, let me phrase it in this way, right? I want to overload this operator plus, right? The plus operator. So since I want to overload the plus operator, simple. I must say operator followed by the plus symbol to say I want to overload the plus operator, or I want my object to be able to work with the plus operator. And then I pass in my parameter. So the parameter that you pass in will always represent the object on the right-hand side. So in my case, obj2 would actually be the parameter for this function. So the parameter, if it's, especially if it's like remember there's two types of operator, two ways of overloading the operator. You can overload the operator as a member function, meaning it's part of the class, or as a non-member. As a member of the class, right, it means that on the left-hand side your of your operator, right? So the way I like to view operators is that think of operators as like the doctor, right? An operator is like the doctor, right? Each doctor specializes in a different type of operation, right? So with that being said, that means that what I have on my left hand side, we call that the left operand. Left operand meaning that the thing that will be operated on the left hand side. And then we also have the value on the right hand side, which is called the right operand. By right operand, operand just means the thing that this doctor, this operator will operate on. So in this case, we would say that, let's say this doctor is a heart specialist, right? They operate on hearts. So therefore they operate the person on the left, the person's heart who's on the left, and then the person's heart who's also on the right. It's just a simple example to kind of get where this terminology is coming from. Operator, operants, operation. So the operation, right? Then the keyword operation would mean what type of operation the doctor does. In this case, the doctor specializes in adding numbers. So this would be the addition operator. That's the type of operation being done. If you are dividing, then it's a division and so forth, right? So with that being said, since now we understand, we have a right operand, meaning that there's a value on the right-hand side. And then we have a left operand, meaning the value on the left-hand side. This sentence here, under the hood, it's actually calling a function. So let me rewrite it here as, let's say sum2. Under the hood, it's actually calling a function. So there's two ways you can actually use this operator. You can say plus like this, or you say dot operator plus to call the operator function plus, right? And then you're gonna put round brackets, right, to show the parameter. So as you can see, this is totally equivalent. This is the exact same thing. But then in this case, in this line of code here, it was implemented as a member function. How do I know? Because I called the method on the object. That's how I know that this was implemented as a member function or as part of the class. So this would be the exact same thing. The only the reason why this syntax is preferable or it's preferred is because this is a bit cryptic, right? As you can see. So instead of always calling a function and saying dot operator plus, C++ allows you to just omit that operator section, and then you can just remove the round brackets, and then now you get something like this. So in essence, this will just be the same as this line of code, exactly the same. That's why even the formula for overloading an operator is you use the reserved keyword operator followed by an operator that you're overloading. So even if I divide the objects, right? So let's say obj div, and I say object 1 divided by object 2. Remember, by default, when you create any object, you can't use this operator, these operators. The only operators you can use by default on an object, right? Operators that can be used by default on an object. Operators that can be used on an object by default. Those operators are the member access operator, or members. I think member, I forgot what's the other term, but then I call it member access, which is just this dot, right? to access members, which is true because as you can see, I called the function here using the dot. And then the other one would be assignment operator. If you don't overload the assignment operator, by default, it's gonna call the copy constructor. By default, it calls the copy constructor. And the copy constructor does something what we call a shallow copy, meaning that it doesn't fully copy everything, right? It's like taking a shortcut to get to the destination. That's the problem with the copy constructor. We would have to overload the assignment operator to do what we call a deep copy. So I'll explain what we mean by deep copy, all those things when you now see it in code. So this is the syntax, right? So to overload the operator plus, right? Okay, I'll just explain it after this. The difference between non-member functions and non-member operator overloading and member operator overloading. How do you get to that conclusion and decide which one is which one to use? So I have all of these operators, right? So as you can see, this plus operator, if I view it in terms of this syntax as like a function, right? It means that the operator takes in an object, and then that object is of type UJ image. So therefore, when I overload here, I need to pass in a UJ image, and then object right-hand side. I like to phrase it this way so that I remember that this is the object that will be on my right-hand side of that addition of that operator when that operator is used. But then remember the problem with passing objects as they are, they can be too big, right? They can be too big, so you need to always pass by reference. But then if you look at this operator here, does it change the object on the left hand side and the object on the right hand side? Nope, it doesn't change them. As you can see, all it does, it takes every single value at that specific index and adds it up to that every single value at the specific index for object 2, and then returns the sum. So that means this object should be taken in by const reference because it should not be changed, right? I should just access the values to sum them up. That's it. And then what should it return? As you can see, it returns an object, UJ image. So it should return UJ image. Remember, it's not always advisable to return the image itself. You can just return the image by reference, right? And then if you are planning not to change this image after this, if you're not planning to change the image after returning it, you could put a const there in front. Put a const there, you could do that. And then, yeah, that's pretty much how you would declare the plus operator function, right? So a simple rule to always remember, right? When you're overloading arithmetic and relational operators, right? Especially when you're overloading those two, the syntax is somewhat always the same, right? So what's the syntax for the operators? So the syntax is somewhat always the same. So you say operator followed by that. I'll just put a hash to represent that operator. As you can see, I explained in the comment, hash just means the operator you want to overload, whether that's plus plus or assignment. So you say operator, and then you take the const const object, right? I'll just say class type. If you check on your notes, it's called class type. So just the class type, it could be UJ image, could be UJ circle, just the class type, the name of a class basically. So it's always going to be in this format, right? And then the return type is going to be, if I'm not mistaken, it's going to be the class type by reference. That's pretty much, remember you can play, it doesn't necessarily have to always be this way. You could also put a const there if you want. It doesn't have to necessarily be that way. But then if you check your textbook, it does explain how everything is. You might think I'm lying, but then everything is honestly in your textbook. So let me show you. So let me open operator overloading. Mm, do, 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 do. So overloading operators. So let me see. Everything is there in the textbook. Let me just double check also if I did the right thing. Yeah, so as you can see, always, okay, you can put the const there. But then the const depends with your operator. Remember, the const just means that the code doesn't change the object, which is fine. To be honest, that's fine. Because, well, to be honest, that's fine. I can put the const there. It's fine. Because when you add, like I said, when you add these two objects here, you're not going to change this object, and you're also not going to change this object. You're just getting the values. So you can append a const at the end of the function definition to say that whatever code is written within this function, it should remain const. It should leave the objects in constant form, the way it found it, or the way it found the information for that object. So you can put that const there. And then where's this is not what I'm looking for. I want the okay, this is okay, this yeah, that's pretty much how, but then I want the proper okay, seems like they didn't. I don't see it. Yeah, seems like they didn't. Yeah, I don't see it. But then yeah, you can just double check the textbook if you want an in-depth explanation. But then it's pretty much the same thing that I'm explaining here. You can put that const there just to make sure that nothing gets changed. I just advise you to just return it as an address to make things simpler, make things faster. You could, but then if you return it as an address, we'll see, though, we'll test it out. If you return it as an address, that means technically this should be a pointer, but then we don't want a pointer. I guess I could just put a constant there, but then that's fine. We'll see if it will give us any problems. So this is how you overload any arithmetic or relational operators. What do I mean by arithmetic? Arithmetic means maths. So plus, minus, divide, multiply, all those operators, they all take this form. And then relational, this is your comparing, right? Your greater than or equals to, less than, equals to, less than, and then greater than, all of the symbols. That's relational. Yeah, and then also your not equals to, that's another operator to check if it's not equals to. And then that's pretty much how you can do that. And then I think we can start now. So you see, allows for a deep copy. When you use the operator, right, it's going to do a deep copy. We'll see why that is. There's a reason why it would do a deep copy, right? So I'll open code blocks and then create a new project and then skip, blah, blah, blah. And then I'll just say perk07 explanation. I'll just save it as that. And then I need to go to my home, code blocks projects, open, next, finish, and then view the manager because I want to see my main.cpp. Okay, so there's the main.cpp. And then I'm gonna create a class, right? I don't know what example to make. I don't know which class to create, but then we'll see what we can do. So let me see. Should I create a? Let me see. I just want to create a simple class. So maybe I can just create a class, but then I need a class to represent an image, right? So I'm gonna call it UJ UJ what PPM. I don't know what to call it. UJ PPM .h. So I'm just going to call it ujppm.h and then save it inside my folder. I just like to remove the underscore included, and then all, and then finish, and then ujppm source file for my implementation, and then next, and then next, ujppm.cpp. And then all, if you don't select all right here, you won't be able to debug your code. You leave that open if you know you're a pro. So I'm going to create a class and call it ujppm, right? Something simple. Okay, this code blocks, don't know why it's doing that. Okay, so ujppm, right? So I'm going to have a constructor. Obviously, I need a constructor, ujppm. The no args constructor, just make it simple constructor, no args. And then ujppm simple, right? And then private, I'm going to have the private member variables. I'm going to create an array, right? Let me see, should I make it a pixel? Let me not make it a pixel. Let me just make it an array of integers, right? We just creating an array. Just that's pretty much it. So, and it's going to be a dynamically allocated array. So in my case, I would make it 2D, right? Which is fine. I'll make it 2D. So 2D, and then I'll just call it pixel. It's actually, I should have said P, is it PPM? No, it's not PPM. I think it's PGM. So I should have called it PGM because PGM, every pixel is an integer. So this is just represents a PGM image, right? Just think of it in that way. And then I'm going to have a, so I need to include a lot of files here. So I'm going to include my IO stream, and then I'm going to include my string header file, because string is a class. String is an object. It's not like int, the primitive types. And then, yeah, I'm not going to say using namespace yet. I'll just leave it like that. So, okay, also string stream. So hash include string stream. And then I'm going to create a function standard string to PGM, and then const, meaning that the code that I enter, they shouldn't change the image. It's meant to just output the image. And then we have that, we have the destructor, we have the constructor. And then I also need the rows and the columns. So int underscore rows underscore coils. And remember, in C++, it's allowed to declare multiple variables in one line separated by a comma as long as they are of the same data type. So that's why this will work. Okay, so far we just, you see this PGM function over here. We're gonna need to use overload an operator called the stream insertion operator to so that when you use cout, we can just use cout straight instead of calling this method. I just want to implement that function so that I'll show you that the code is the same. So far this is what we have, right? And then I'll have default rows and default columns. So static const int default rows 500 by 500. So static const int default calls is equals to 500, and then default pixel static const int, because at every single index, right, at every single pixel is an integer type. So that's why I'm saying const int and not const RGB color. I'm doing a different image called a PGM image or a grayscale image. So default pixel would be, and it is values between 0 and 15, if I'm not mistaken. PGM Wikipedia. I think it has values between 0 and 15. Yeah, okay, so there's the file formats, right? I'm doing the gray one, grayscale PGM, which is going to be, let me see, P2. So is it P2? Yeah, it's going to be a P2 image. You guys have been doing a P3, this one will be a P2. So I need to check how you structure it. So this will be a PBM, right? This is not what I want. This is PBM. I want a grayscale. A PBM is also the same as a grayscale because it is integer. Every integer represents an actual picture, a pixel. P3, every set of 3 integers represent every pixel. So as you can see, this is how it works. You output P2, and then you can draw that. I could draw that, but then for the sake of time, I don't want to waste time and try to draw that. But then it's simple to draw. So I'm going to go back here. So since it's, what's the maximum intensity again? 15, yeah. So the maximum is 15, 15 being white, and then 0 being black. So I'll just make it somewhere in between 0 and 15. So let's say 8, which is, I don't, it's just grayish, right? So I'll use 8, which is going to make a grayish image. And then I'll copy these methods and put them here. But then before I do that, I need to include my header file, ujppm.h. And then those are my constants, right? I'm not gonna put all those things like enforce range and all. I'm not gonna do that. Definitely not gonna do that. That's gonna make the video too long. So using namespace standard, but then just know that you have to enforce the range. So ujppm constructor, right? And then this would also be ujppm. Copy this, paste, and then there we go. And then here, right next to the function name. And then, yeah, so the PGM image, right? It actually works the same way as the PPM, just slight variation, right? So instead of outputting P3, we output P2. So I'm going to do that. So I'm going to need to create a string stream first. Call it SS in. Or just basically, I'm basically mimicking cin. And then return that string stream converted to a string. Because remember, a string stream is a stream of strings. So it's like an array of strings. So this function expects me to return one single string. So I call the .str function to convert that string stream into one string. So those multiple strings will be converted to one string. So now I can see out, right? So I can say cin to output P2 because that's the image, and then end line character. And then I need to output the columns, right, which is underscore calls, and then followed by a space, and then followed by the underscore rows. And then I move on to the next line, the end of line character, and then the maximum intensity, which is going to be 15, and then end line. And then I'm done with the first part. Now I output the pixels, right? Now I'm gonna go through all the pixels. Int r is equals to 0, r is less than underscore rows, r plus plus, and then for int c is equals to 0, c is less than underscore calls c plus plus, and then I output the pixels, right? So cin, what's the pixel? It's pixels in that specific row and column, and then followed by a space, right? The space is there, as you can see, there's a space between every single pixel. Every single integer, there's a space. So that's why I'm putting that space there. But then after every single row, right, I need to insert an end of line character. so that it moves on to the next line, so that it forms the grid, right? Remember, it needs to form this grid format. So this first line here will represent my first row. And then in order for me to go to the next row, I need to move before I move on to the next row, I need to move on to the next line. So that's why I did it after the for loop for columns, because before after that for loop, I'm gonna go back up, increment my row by one, basically move on to the next row, and then compare if my row is less than the number of rows, not row, the number of rows. If this is true, then it will execute again, and so forth. So we are done with the to_pgm function. That's pretty much it. Then now we need to allocate memory. We need to yeah, basically allocate memory, but then also initialize our rows and columns, right? So underscore rows is equals to default rows. I'm not gonna put a parameterized constructor here. I'm just making a simple example. So default calls. So I have my rows and my columns initialized to the default rows and default columns. Then now I need to instantiate the, or allocate memory for the array. So underscore pixels is equals to new int pointer because each pointer represents a dimension. So to allocate the memory for that pointer or for that dimension, I replace the pointer with square brackets followed by the size of that dimension. So underscore rows. I will just start with rows. You can start with columns, that's totally up to you. And then less than underscore rows r plus plus. And then now for every single row, I'm gonna allocate memory. Remember, we had 2 pointers, right? I've already allocated for this one, the outermost. That should disappear at this point. Now I'm left with this one pointer, right? So I need to replace that pointer with square brackets followed by the size, which is underscore calls. And then now after doing this, I need to go through each column to initialize it to that default pixel. So C++, and then underscore pixels for the specific row and column is equals to what? The default pixel. Because remember, this is a default constructor or a no args constructor, which is technically the default constructor because that's the default one that will get invoked or called if it didn't implement, if it didn't create a parameterized one. And then here I'm going to deallocate, right? So for int r, I'm gonna go through every single row and then delete that whole dimension for the columns at every single row. So underscore pixels r. And then once I'm done, I delete my whole container for my row, right? Because I'll be left with the row's dimension. So I need to delete all of it. And then remember when we talked about pointers, since we're dealing with pointers, we need to always make the set it to null pointer so that we get the segmentation fault error. So if we try to dereference to a pointer or a location that's non-existent, when we get this error, it's a clear indication of what's the issue. If you don't do this right, it'll just your application will just jam and freeze. You won't know what's the issue. So that's why we have to set it to null pointer, basically set it to 0 or nothing, so that when you try to dereference memory that has been deallocated, it's going to give us a segmentation fault error. So that's pretty much it, right? We are done with the class, right? So let's create the object. Before we create the object, I need to include the header file because it needs to know where that object is. It's inside that header file. So it's uj ppm, right? Obj ppm as usual, right? And then remember with objects, right? If you're using the no args constructor, I know it can be tempting to put those empty brackets there. Don't do that. That's not the syntax. C++ doesn't like that. It strictly says that if you have these round brackets, you only the moment you use round brackets, it means that you're calling it parameterized one. So if you just leave it this empty, it's expecting a parameters, then it'll be like, okay, where are the parameters since you've used round brackets? So that's why you always need to leave it empty. And then here, I'm just going to see out my string, right? Inside my to_pgm function. End line character. You don't need to put the end line, doesn't really matter. As long as you send it to cout so that we can see it on the console. So now I'm going to build and run. Okay, there's my code. Let me do this. Let me change the terminal. And then let's run it again, build and run. So there we go. So now it's a bit bigger, right? So there's remember I initialized it to 8 because I want it to be somewhat between grayscale, right? So as you can see, it's 500 by 500, 15, that's maximum intensity. There they are, the pixels. And then now what I would do is I need to convert this image to I need to convert it to an image, right? Which is simple. So what I'm going to do is I need to find the folder. It's in zip, it's in the home. Okay, so let me do this. Copy this. Okay, no, copy that. Doesn't matter. Okay, let me just copy the whole thing. Copy that whole location, and then Control Shift this. Oh, my bad. CD, because our CD means change directory or move into that directory. And then ls, there's everything, right? So remember, we have multiple .cpp files. So I need to say G++. Before you ask, G++ is installed on my laptop. As you can see, it is there. So G++, call the compiler or the compiler or the translator, and then compile everything. That's what that asterisk stands for. Everything that ends in .cpp. And then after you've compiled everything, -O to say all the object files or the machine language. Remember, we translate C++ to machine language, which is zeros and ones. So the translated file should be named main or out. It doesn't matter what you name it. And then I press enter. I should have a main executable. Anything that's in green on Linux is an executable. So I can just say ./main to execute it. But then I want to redirect the output to a file. So that output that I was seeing on the console, I want to redirect to a file. So I put the greater than sign to say whatever is displayed here after running this, send it to whatever's on the right hand side of this greater than sign, which is this file that I'm going to call image.pgm. Remember, the extension is important. It's a P2 image. It ends in pgm. And then ls. So let me see if it can open here. Okay, let's just do this. So cat image.pgm. So this just reads whatever's in that file. Cat, that's what it does. So you see that file has that same output that we had, right? So now I'm gonna clear that. There's the image is there. Let's go run. Let's go open it, right? So code blocks project. There it is. There's the image. And then I'm gonna double click. As you can see, the image is gray. There's the image grayscale. So we have our image, that's fine. So let's do a bit of operator overloading now, right? Let's start with before I start with operator overloading. Okay, time surely does fly. So before we go to the operator overloading, so far we just focused on the thing is there's quite a lot to explain. So far we just focused on creating the class so that we can add the operators, right? So let's talk about the difference between non-member functions and member functions. How do you know to make which member function? So to make it a member function, right? Member function. You make it a member function only when excuse me, only when the left operand, right? The left operand. Remember, I talked about operands somewhere here. The left operand means the value on the left hand side of the operand. When the left operand is of type class type. So by class type, it means that it's either a UJ image, a UJ shape, or basically the class, meaning the name of the class, right? I'll just put it in brackets to say the name of class. If on the left-hand side is the name of the the data type is the name of the class, then you have to make it a member function. And you make it a non-member function when it's the opposite. When the left parent, only when the left operand is of non-class type. It's not a class type. That's when you make it a non-member function. And to make it a non-member function, we haven't talked about it. You use the before. So let's say this is where it returns, right? Before the return type, you put the keyword friend. So before the return type, you put the keyword friend. The keyword friend. And then a friend function or a non-member function, we can call it a friend function or a non-member function. It's one and the same thing. So a friend function, right? It means that you're a friend, right? That person is your friend. So doesn't your friend know your secret? Like in this case, let's only view it in terms of like really close friends. Obviously, your friends will know your secrets, right? Basically, something that is only known by you, which would say that thing is private. It's only known by you. And there's also protected, and there's also public. There's all of those things, right? So basically, the friend function has access to all: private, protected, public, even private. It has access to everything, all those members of that class. Even though it's not part of the class, I've used the keyword friend to say this is a friend. So allow them access to anything that's private, which is true because that's how friendships are, right? You share secrets. Like, okay, yeah, for example, you like telling your friend, okay, I have this crush on this girl and things like that. All those things that's something that you've only kept to yourself. But then since you now have a friend that you trust, a close friend, you can share that thing that's private. So therefore, the friend function will have access to private members. Keep that in mind. And then remember the rule for making it a member function. It's when the left parameter or the left operand is an object, or it's of class type or the name of the class. If it's not, then you have to make it a non-member function. Basically, you put the keyword friend. And then remember, when you're implementing the file, when you implement the, just like virtual functions, when you implement the friend function in the implementation file, you omit the friend keyword because it should only be in the definition of the class, which is the header file. Just like the keyword virtual, try putting it, you're gonna face serious issues. And remember, it's not part of the class, so do not put the scope resolution this. This means this constructor is part of the UJ PPM class, it's part of it. You don't put this because it's not part of that class. So let's overload some operators, right? Let's say I want to add, okay, so because it's going to add all these individual pixels, right? That means it's going to look at every single pixel. And if you looked at our pixel at every single index, it's a value 8. If I want to add another pixel using the default constructor, it's going to be 8 plus 8, which is 16, which is going to exceed the maximum intensity of the pixel, which is going to be 15. So therefore, I'll just change this to a 5 so that when I use the plus operator, it's just going to be, let me say, should I say 7? Let me make it 7. Because 7 plus 7 is 14. So if I say 7, it's going to say 7 plus 7, which is going to be 14, which is still less than or equals to 15. So that's why I changed this. That's why I'm changing this to that, because I don't want to exceed the maximum intensity for the image. I could technically make it an RGB image, doesn't matter. I just chose the simpler approach. So how do you overload? Remember the syntax that we talked about, you have a return type, and I'm overloading an arithmetic operator. Remember the rule for overloading an arithmetic operator. And then you use the keyword operator. which is reserved. As you can see, it's highlighted in blue now, followed by the operator, and then followed by the parameters. And then don't forget the const keyword at the end to make sure that these objects are not changed. So since they're not changed, that means I need to create a temporary object or a local variable within the function and then return that variable since I have this const. So let's change it now. So what operator am I overloading? I replace the hash with the operator that I'm overloading, which is a plus. I'm overloading the plus operator because I want to be able to add two objects together. And then the parameter will be, remember, it's always, they said it's const. That's the formula in the textbook. It's const class type, meaning the name of the class. In this case is UJPPM. So this would be the syntax. So in my case, class type is actually UJPPM by reference, right? Which will be I'll just call it obj right-hand side because this will be the right-hand side. This will be on the right-hand side of the plus operator. And then the return type, what should it return? That's up to you. I would just return a UJPPM by reference, right? By address. Then I'm going to implement it. So as you can see, this one it doesn't have the friend function before the return type. I don't have this. So therefore, this is part of the class. So therefore, I have to add that scope resolution operator to say that it's part of this class. So I'm going to do this. And then I need to say that this part of UJ PPM scope resolution. So this whole keyword, right, the operator reserved keyword with that symbol, it actually becomes the name of the function. As you can see, that function takes in a parameter. So the operator is actually a function. And the function for the plus operator, the operator is called operator plus. That's the full name of the function. So function name is operator plus. So the name of the function for the operators, right? It's always the keyword operator followed by that symbol or the operator you're overloading. So how would you overload, right? Remember that I'm going to have this is on the right hand side. So what is my left hand side? That's when I need to use this keyword to get the current object, which will be on the left hand side. So to get the current object, remember it's a pointer. This is the name of the pointer. It's this. But then I want to get the actual object, so I need to dereference. So I need to store that. I'll call it UJ PPM OBJ left hand side, right? My object on the left hand side is my current object, which is that address dereference. Go get the actual object, and then I store the object. So now I have access to the two objects. Now I can sum up the values at every single pixel. That means I need to do a for loop or two for loops. So int r going through r0, r is less than underscore rows, r plus plus, and then for int c is equals to 0, c is less than underscore calls, c plus plus, and then there we go. And then now I need to add up these values, right? But then I need to store the answer in an object, in another object, right? Why? Because there's the const keyword. That means I cannot change this object, the current object, and also the one that I'm taking in. I cannot change it because it is const. That means I need to create a temporary object, UJPPM, obj answer, which will store the answer. I'll just call it obj answer. So it's like what I'm doing here. See what we did here. C in this case will be obj answer. Obj left hand side will be A. Obj right hand side will be B. So yeah, that's pretty much what I'm doing there. That's why I'm creating an extra object or an extra variable. So that means obj answer will store the answer of adding those two pixels, right? But then I need to add all the pixels at every single index. So I need to say dot underscore pixels. In that specific row and column, take the sum of the pixel on the right hand side and the pixel on the left hand side. So this will be obj left hand side dot underscore pixels in that specific row and column. And then, come on. And then add it to the object on the right hand side its pixel RC. As you can see, no pun intended, as you can see, we added the pixels on the left hand side, which is my current object. Basically, remember this, when you use this keyword, right, it means the object that's calling this function. That's what it means. So the object that's calling this function basically will be on the left hand side. As you can see, obj1 is the one that's calling that function operator plus. So therefore, it will act as the value on the left hand side. And then the parameter will act as the value on the right hand side. Remember, there's two ways you can use this operator, like this, or by literally calling the function like this. There's two ways. I'll show you those two ways, and you see that it will work. So the output that I'm expecting is the answer 14. That's the answer. I need to see 14s on the output. But then remember, it needs to return in UJ ppm. So I need to say return which one? The one that has the answer, which is obj answer. Let me see if, yeah. So build no error, because there's that const keyword. If I had done something weird, like on the left hand side, I update the left hand side, that was gonna cause an error, right? What do I mean by that? So if I say left hand side, because this is allowed, right? Remember what this means, right? It basically means something like this. If you have int a and b, right, I can say a is equals to a plus b. That's literally what I'm doing here. As you can see, obj left hand side, obj left hand side. So I'm updating obj left hand side by taking the value of b, or in this case, obj right hand side. So this is going to crash because of what? The const keyword. It sees the assignment. You're trying to change the object itself, which is not allowed. That's why we just created a temporary object, then stored the answers, and then return that object. So I'm going to delete that. And then let me show you that it should give me an error there. Okay, it didn't give you an error, but then the const keyword should give you an error because I'm assigning. Or maybe it's not giving me an error because I stored it. Let me do it this way. Let me just do this. Let me say this. So let me just say this. Okay, I don't know why it did that. Why is my code blocks doing that? So let's open the project again, and then view manager. Okay, so there it is. So there's obj ppm, and then now it's gonna force me to end the files again. I don't know why it's making me do that. Yeah, Linux is not friendly. So there we go. Okay, let me change the settings. I hope it doesn't do the thing again of just exiting on its own. And then okay, so there's our code. Then I'm gonna minimize that. So this should have crashed, but then it's fine. Maybe on your side it's gonna crash. So just make sure you create a temporary object to store the answer, and then return that object. And then now I can add the objects, right? So we ran this code and we saw that it does display the pixel, right? Which is fine. So that means the image now should be close to white. Yeah, it should be white, as a matter of fact, because 14 is one, it's one less than 15, which 15 is the maximum, which is a white. So that means it's going to be white. So I'll have obj ppm, or I'll just call it obj1, right? Keeping it simple, and then uj ppm obj2, right? And then uj ppm obj answer, and then I add up those two objects. So I can, like I said, you can call it in two ways. You can say obj1 plus obj2. It's going to go into your class and see if you've overloaded this operator first. If you have, then the code will compile and then add. So let's see if our output is going to be 14. Okay, segmentation fault. Why is it saying that? Because we haven't reached here. That's a weird error. Why is it saying that? Okay, let me do this. It shouldn't be having that error. I don't know why it says segmentation fault error. Yeah, I don't know why it's doing that because we haven't reached the return keyword. By the time you reach the return keyword, that's when it's gonna complain and say, or maybe it wants the copy constructor. I don't have a copy constructor, right? I don't have the assignment, right? So what I would do is I would do this. I know it's cryptic, right? I know you're not gonna like this, but then I'm gonna say obj1 plus obj2. Let's see if this would work. Because I know adding those two things will return an object. So whatever that object will be returned, converted to PGM. Let's see if that's gonna work or it's gonna complain. Why does it seem like my code block? Something is not right with my code blocks. duh, 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 duh. So I think I need to change an editor since I'm on Linux. I need to change an IDE. Code block is not working the way it's supposed to work. Segmentation fault, but how? Because I didn't. Okay, let me do this. Let me delete this and then build and run and see. Okay, it runs well. So the problem is with output. Why is it complaining with output? Okay, I don't know why it's complaining. So I think we need to just create the assignment operator. So how do we create the assignment operator? So the assignment operator is almost the same as the copy constructor, right? But then it does what we call a deep copy. I was actually supposed to implement based on this, but then it's fine. Okay, I did. You see, it adds both images and then it adds both images at each index and divides by 2 to get an average. Okay, so to get an average and then okay, no problem. And then allows for a deep copy to be assigned. So let's start with that, right? I don't think I need to overload all the operators. That will make my video too long. I don't think I need to overload all of them. So to overload the assignment operator, right? Remember, it's always the return type, as always, followed by the operator name, which which operator am I overloading? The assignment or equals, operator equals. And remember, it's exactly the same as a copy constructor. That means it's going to take a const object, just like a copy constructor would. And then there we go. But then I shouldn't put the const keyword at the end there. Why? Because this is an assignment. It's meant to change this array. It's meant to change my pixels. So that's why. And then return type, what should it return? So it should return a UJ image, not UJ image, UJ PPM by reference. But then after returning it, I don't want to make change. I don't want you to be able to make changes to that object. So I'm gonna put a const to say that this UJ PPM that's going to be returned, because if you return it by address, it means that you have ability to make permanent changes. I don't want that. I just want you to get that object and not be able to make permanent changes to it. So I'm going to get it by address, but then const there to say that you can't change it. And then copy. And as you can see, it's implemented as a member function because on the left-hand side, it's of type UJ image. As you can see, or UJ PPM, I mean, as you can see on the left-hand side of the plus, what do I have? It's OBJ LHS, right, which is a UJ image. So therefore, I made it a member function. If it wasn't the case, then I wouldn't make it a member function. And then UJ PPM colon. So to assign, right, the way the code works for the assignment operator, it's simple. I always need to check first my address. So I need to check if my address, remember the name of the pointer is this, to check this current object. So what does this mean? It means that if you call, let's say you call obj1 dot to pgm, how does it know to call the to pgm for obj1? Because obj1 will basically be this. Then now when you use this, it knows, oh, you mean for obj1. And then the same applies for obj2. It will know, oh, you mean obj2. Because each object maintains a pointer to itself or an address to itself. So I can use that to my advantage, because I want it to affect all instances. So by using this keyword, it's going to affect all instances of this class. So if this, or basically my address, this address is not equals to that object on the right hand side, but then I need to get that object's address, because this keyword returns an address, right? Because remember, this is the address of the current instance calling this function. Calling operator equals, that's what it means. And then when you get the object, when you dereference this, it means you get the object at that address. That's pretty much it. So if I used it without the dereference or the pointer, it means I'm looking at the address. That's why I said get the address of the other object and compare the addresses. If they're actually at the same address, that means they have the same values. So I should make sure that they are not equals to before I try to copy. Because what's the point of copying something that's already the same? So that line of code is to avoid something like this. Let's say you have int x is equals to 10, int y is equals to 10, and then int z is equals to, okay, int z, let's say int this, okay, let me say now x is equals to y. I'm assigning, I'm taking the value of y and putting it inside x, but then you see they're actually the same. So if they're the same, we should just avoid that. So we should just avoid assigning. That's what that if statement is for. It says check my address compared to that object's address. If they are this, if they are not the same, then you can assign. So to do a deep copy, right, there's many things that are involved. It's always in this order. You delete first, basically to delete to make sure that it's empty, ready for use, and then you allocate, right? And then after allocating, then you copy. You transfer the data because it's called an assignment operator for a reason. So here in this line here, the copy section, you could just create a copy construct, a helper method. This is where helper methods are very useful. It's just that for the sake of this tutorial, I'm not going to create them. I'm just going to write the code as it is. So the delete, it means that, okay, let me see if I can create it. So delete, you see that I'm just going to repeat this code to delete. So you see, I'm now repeating myself because that's how you delete the pixels. So I'm just going to repeat that code for deleting the deleting part. And then the allocating part, I'm just going to call the code inside of my constructor as it is, all of it. I'm just going to call that code. But then where there's default rows and default calls and default pixels, I'm getting it from the object right hand side. Or I could just, yeah, no, it's fine. It's fine. I'll just make it default. Okay, default, the rows and columns, I need to make sure they match with my object that I'm trying to copy from. So this is the object on the right hand side, or you can call it obj original, that's fine. So now I'm just going to copy this code. That's why you need helper methods. I'm not going to create them for the sake of time. So after doing deleting, because deleting, remember, we need to make sure that we're of the same size. Can you take a 2-liter Coke, right, and then pour it into a cup and pour all of it in one go without it spilling? You can't. So therefore, we need to make sure that the containers are the same size. I actually have another 2-liter so that when I transfer all of these contents from this 2-liter, there won't be any spill. It won't spill. There won't be any data or any Coca-Cola lost, something like that, right? So I need to make sure they're the same. So how do I do that? I start by deleting, remove whatever nonsense is there, delete it. And then allocate it means to make it the same size. So make them the same size. So think of the 2-liter Coke example. If I'm pouring 2 liters of Coke, I need to pour it in another 2-liter container. I can't pour it 2 liters into a 1 liter. It's going to spill. It's going to overflow. We call that overflowing because it's spilling, it's overflowing, it's going beyond the maximum capacity. And then I'm just going to copy and paste that code for the constructor because that's how we allocate. That's why we create helper methods for this. So my rows should match with what rows? The right-hand side's objects rows. So I'm going to say this dot underscore rows, and then object right-hand side dot underscores columns. The default pixel is fine because at the end of the day, I'm going to override it. So I can leave that default pixels as it is. When I copy, it's going to change the pixels. So I can leave default pixels as it is. And then I'm going to copy now. So we don't have the copy constructor. We didn't implement it, so it's fine. I'll just say int r, or write the code from scratch. Int r, while r resistant underscore rows r plus plus, and then for int c is equals to 0, c is less than underscore calls c plus plus, and then now I can copy, right? So I call my pixels array rc is equals to my object on the right hand side dot underscore pixels array. So I copy 1 pixel at a time. If you want to, you can. You don't have to. But then if you want, you can just so that you see the left hand side and right hand side. You could say this object and then you dereference by using the arrow to get the pixels. So it means this object on my left hand side is equals to that object on the right hand side. So left, this object is equals to my object on the right hand side. You don't have to put this, right? It's not necessary. But then for the sake of you releasing it, you can do that. And then now we are done. So after this if statement, it expects us to return an object, right? Don't pay attention to the const and the address. They will be applied to the object itself. So don't return that object. Don't return the address because you see that it expects address. No, it's going to get the address of that object that's returned. So you need to return an actual object. So if I come here and I say return this, it's going to crash. It should crash because this is not what is expected. It wants you to return an object, usually ppm, and then it's going to take the address of that object in constant form to make sure that, or go to that address, but then const to prevent you making permanent changes at that location. So let me show you the logs. It might give you, yeah, invalid, you see, const blah 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 of type pointer. You see, it's a weird error. It just means that I expected an object and you provided an address. So to get an object, remember pointers, you point or go to that location to get the actual object. So now when I build it, error is gone. So now we have the assignment operator overloaded. We are done. That's pretty much it. You delete, allocate, and copy. Always remember those words: delete, allocate, copy, delete, allocate, copy, delete, allocate, copy. Always in that order. But then to avoid copying the same thing, like here, x is 10, y is already 10. Why should I copy here? Like, why should I copy? You see, there's no need to copy. That's why there's that if statement. So if I go back here, if this, remember the if statement executes only if this is true. If they're not at the same address, meaning that they don't have the same values. If it does not the case, it's going to skip that and just return myself, return that object with no changes because it's the same object. They have the same value. It's 1010, which makes your program fast. Because think about it, all of these for loops need to be executed. If you copy again when there's no need, all of them needs to be executed. All of this code. So to avoid that, if they are the same, then there's no need. So like, for example, here, you see my objects are the same. There wouldn't be any need to say obj1 is equals to obj2. Here it's going to skip the if statement because the objects have the same value, the same values. So it's going to skip that. So if let me try to output object one, it doesn't copy anything because the objects are the same. Where is this error coming from? That's one thing I'm not understanding about this thing now. It's complaining about segmentation fault. How when there's no segmentation fault? Because there's the there's the oh, but then this should be fine. Let me try something. It should technically it should work fine. I don't know why it's doing that. Let me use the C asset library, right? To call the function called asset. Asset just means make sure this condition is met, right? So how do I make sure? I say asset and then I call that function, and then here I pass in the boolean, the condition that I want it to be met, or that I wanted to make sure of. So make sure what pixels is equals to, or is not null, is not equals to null pointer. Basically, it's not pointing to nothing. If it's not pointing to nothing, the law of negation, right? Not nothing is equals to something. So therefore, it means that it continue only if there's something to delete. If not, then don't. Yeah, so it's still giving me that error, but then this safety, this line of code needs to be taken into account. So what issue is there here? It seems like it doesn't want me to call. Yeah, it seems like it doesn't want me to call 2pgm function, because the moment I call 2pgm, like you see, when I do this, I don't know why it's doing that. Maybe on your Windows it's gonna run. Okay, it's still the same issue. Okay, so what if I do this? Is it the assignment that's the problem here? Okay, it's displaying now. So I think maybe it needs the copy construct. I think that's the only plausible reason behind it. Let's just put the copy constructor. But then we have the assignment. I don't know why it's complaining about the copy constructor. So copy constructor uj ppm by reference obj original. You see that now we're going to have a lot of repeated code. That's why we create helper methods for that. Those helper methods, you didn't understand why they were needed in those practicals. This is why they were needed. When it comes to operator overloading, they're needed. Then I will just chain to my I'll just chain to my other constructor, right? Okay, no, I'll implement this one and then chain that. So let me copy this code. So copy, put it here in the copy constructor. And then here it's obj original dot underscore rows, and then obj original dot underscore calls, and then just leave that to the default pixel, right? Mm, okay, no, I don't need to. This is a copy construct. I don't need to do all of that. I think I'm gonna need the. I guess I'm gonna need the parameterized construct, but not really. I don't think so. I, I, I don't care about chaining, so I'll just do this. So I'm gonna have this int c, because 0c is less than underscore calls c plus plus. I think there's a problem with my code blocks. I think that's the main issue here. So same thing here, copying rc. This goes to obj original dot underscore pixels rc. as you can see, this is a shallow copy, right? Because what would happen if my pixels array is smaller than the object that I'm copying from? Then that means it won't copy everything from the original. It's gonna copy only a subsection, meaning that this is a shallow copy. So keep that in mind. So why is it complaining with aborted invalid pointer? Why is it saying invalid pointer? Because this is my left hand. Oh, let me just double check something. Let me set the C++ standard, the language, the compiler. Maybe that's why. Okay, that's not the case. Why is it saying invalid pointer? Because they created it very well. It's perfect. You delete right first, and then you allocate, but then you need to make sure it matches your object's right hand sides, rows and columns. Yeah, you allocate, blah, blah, give it a default pixel, and then at the end of the day, you need to copy. So I'll just remove this. Maybe it doesn't like that. So let me just remove this and see if maybe now it gets better. Still the same thing. I guess maybe on my computer, on my operating system, that's the problem. On yours, I think it should run. Yeah, it should run. Yeah, that's the code. It should run. I think it's just my code blocks. That's the one that's having problems. So we have this, and then the assignment should be working perfectly fine. Okay, let me see. Okay, so the other operators, I think you guys should be fine. And then this one is easy. The allocate to be accessed and updated, right? So this one, you take in a row and a column. It's basically like a mutator. It behaves as a mutator and an access at the same time, simultaneous, right? They told you it can be accessed and updated. So it can be accessed and mutated. And then when it comes to things like double indexing, the double indexing operator, right? Let's try that. The comparison one is straightforward. You just return a Boolean. You compare per pixel basis, right? You just compare each pixel on the left, the pixels on the left hand side to the pixels on the object on the right hand side. And then that's pretty much that. So I think I need to show you only two, right? The indexing, the double indexing one, and the streamization operator. The streamization operator is basically your 2PGM function, yeah, or 2PPM function. It's basically that code with slight variation. So I'm gonna say operator overloading to PGM function, and then what else? So let me see. Will it be a member function? Yeah, because you're accessing a pixel, and what's on the left hand side is going to be an object. So yeah, and by default, if you check your slides, when you overload operators like when you overload operators like the single indexing, and then this one invocation operator, and this one, by default you need to make them, you must, it's a must, you must make them member functions. That's the only way they can be implemented, as member functions. So I'm going to go back to my code and then implement it as a member function. So it's double indexing, right? So double indexing is actually not possible, but then let's see. So at every single pixel, what am I trying to get? I'm trying to get an integer. At every single pixel, it's an integer. So the return type now is going to be an int, because the pixel, at every single pixel, each pixel is an integer. In your case, it's going to be RGB. So int, it returns an integer. The name of the function is operator, followed by the operator. What's the operator that I'm trying to overload? Is this double indexing, right? It's not possible to double index. You see it just now. And then you should take in a row and a column, right? That's what you're trying to do, right? This is what we're trying to do, right? So let me show you the error. It's really annoying. You can't overload the double indexing. Array, blah, 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 error. You see error in the declaration. You can't overload. So how can you overload it? So there's a trick. You can overload one of them and then overload the other one within this class, which is really annoying. So I'm going to overload. You can overload the maximum of one. You can't overload the double indexing. You only can overload single indexing. So I'm going to create a class named ujrow.h and then save it inside my folder, and then remove the underscore included, select all because I want to be able to debug the code, and then create uj source file, and then create uj row.cpp. So this will represent my uj, or to get one row. And then I'm going to create a pointer to that object, basically composition. And then, yeah. So what I'm going to do is I'm going to say hash include uj row.h, right? And then this class uj row, class uj row. Hopefully I can still remember some of the things. But then I remember very well that you cannot, because it's not in the slides. That's the thing about this one. It's not in the slides. So to overload this, you can say public that I'm just going to create some constructor, parameterless constructor. You could create all of them, right? Copy, blah, 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 all of them. And then a destructor, uj row to deallocate, and then private. So what's the private? It's going to be a one-dimensional array. So underscore row, just going to be representing one row, right? So I want to, since you can only do single indexing, and then I'm going to overload that operator. It's going to return a row, an integer. So int operator, single indexing, it takes in a row. And then obviously I'm going to put a const there because, in my case, they said we need to look at the slides, the PDF, I mean. It says it allows to be accessed and updated. So the simple difference is the const. The const is when it can be accessed only. So it basically works as a mutator, as an access, I mean. So it's like, for example, int get row, right, and then const, like this. In our case, we need to get the row that we're trying to get. Oh yeah, even here. Yeah, so it's basically the same thing. But then instead of calling a method, we just use an operator, which makes it convenient for us. But then in our case, you need to be able to change the code. So I need to remove that const at the end because I need to be able to change the code or update it. And then that's pretty much all you need. You can also create your default columns and default whatever. You can do that. But then remember, this pointer here needs a size. So I'll take in a number of rows, right? It takes in the number of rows since it represents the rows. And I'm gonna create a parameterless one, or a no args constructor. And then here I'm gonna create underscore rows in plural, right? It's underscore rows, and then this just represents the row. And then that's pretty much all you have to put here. I don't see anything else that you need because we just want to represent one row or index once. And then this will be uj row scope resolution operator. And then we have that. And then I'll just chain it to, so now we do constructor chaining, chain it to my other constructor. We should have default rows that I need to make as a constant. So I come here, I say static const int default rows is equals to 500. You can put in any value there. It's just default rows. And then here I'm going to implement the parameterized constructor, which starts by setting the underscore rows to that rows that I'm getting from the user, and then allocate memory for that one-dimensional array. Int r is equals to okay. What am I saying? So underscore row, I've called it row, is equals to new int pointer. Since we have one pointer, one dimension, I only have to replace one pointer with square brackets followed by the size of that dimension. And then I could give it a default pixel. You don't have to, I'm just putting it there. But then it's important to initialize, right? So the default pixel will be 0, which is black. So it's always important to initialize your variables. So let's do that. So int 0 less than underscore rows r plus plus. And then remember in C++, if a for loop has one line within that for loop, if that for loop is one line, you can omit the curly braces. But then don't forget to press to indent. You just press tab to indent. And then I'm going to say this should be underscore row, and that specific row is equals to my pixel, right, which is default pixel. There we go. And then we've initialized it. And then the destructor, same thing. We are just destructing or destroying the memory or deallocating. You could put the CR statement there. That's up to you. And then this will be deleting, right? So since we have one row, I just write delete. That's it. Because I have one dimension. This one row is not pointing to another dimension. So this is just the one line that I need to put there. Okay, also setting it to null pointer. Let's go to null pointer. And then now we do the single indexing, which is very straightforward. Because it's like accessing, right, your accessor. So this, I can just say return underscore. Okay, this is not going the way I planned it. My naming. Let me say pixel row means the row for that pixel. Yeah, because the way I've named it, it's horrible. Pixel row, pixel row, pixel row, pixel row for that specific row, right? And then that's all you have to do. That's all you have to do. And then now I have the class that represents one row. So here I don't need to index everywhere, right? I just need to, because you can only do single indexing. So I put single indexing, but I'm going to take two parameters. The trick to this is that I'm going to use that uj row to represent my row, right? So remember my pixels is two-dimensional, but then I already have something that represents the int pointer. What's that? It's this class. It represents one dimension, which is called uj row. So I'm going to copy this and make it uj row like this. Because then under the hood, uj row is just int pointer, right? So it's just going to replace that. So under the hood, uj row is just int pointer. So you can imagine whenever you see uj row, just replace it with int pointer because that's how it's implemented. And remember, when you're dealing with composition, like I always say, and I'll keep saying it again. In the header files, you only put the for declaration. That's it. So uj row. Why for declaration? Are we implementing uj row here? Nope. We're just declaring it. We are doing the for declaration so that it stops shouting at us or moaning at us that uj row is not defined. Right? Let me show you what happens if you don't put it. To say uj row is not defined. Okay, I think The operator is fine. I don't know why it's complaining. Let me just check something. Oh, must only have one argument. Okay, so this would take in a column. Yeah, okay, so it seems like it forces you to have one argument. So build. So that's not what I'm looking for. So this is the one that I'm looking for. Why is it saying pix? Oh, so the destructor was having issues. It's saying underscore pixels is not declared. Something is not right with the destruct. I think that's why it was showing those errors. We'll fix that just now. So UJ does not name a type, so it doesn't know what UJ row is. So what you can do is you can just create a do forward declaration, basically an empty class forward declaration, so that when it sees it down there, like, oh, UJ row is a class. But then when you go to the UJ ppm.cpp file, when you implement it, you need to include the whole header file to say UJ row, because you're going to call methods for that UJ row or things that are inside that class. So why is it saying underscore pixels? Class UJ row? No, that's not the. So let me do this. Oh, because I've changed it to UJ row, that's why it's complaining. But yeah, so we need to be a bit smart here. So this will be UJ row like this. I think this, if I'm not mistaken, this is exactly how it should be. So now let's go and check, make the changes, right? So let me do this. Oh, that's why. But then it will, okay, that's why. You see some mistake that I made here. I'm calling the default constructor and it has no code. So that I think that's why it was giving that segmentation fault, because there's no memory allocated. Yeah. So I need this code here. I was thinking of creating a parameterized constructor. That's why. And then I just changed my mind. Okay, just give me a sec. Yeah, I think this is the main reason was complaining, because I was like, why is it saying segmentation fault when the memory is allocated? Yeah, this thing of changing things and not checking if there's places where you change that you shouldn't have changed, it's a problem. So this constructor, and I'm using the default constructor. If you check here, I'm using the default constructor. Obviously, it's going to complain about UJ row because, yeah. So this points, this now point, this should now, this is now type UJ row, right? Because remember, UJ row is now representing our pointer. So it becomes really annoying because you have to go and change everywhere. That's why we do constructor chaining. In my case, I didn't do it, so now I have to go change everywhere. And then let me see, let me double check something here. Oh yeah. So yeah, it's going to be, I hope you guys can understand. It's going to be very cryptic, right? Very weird. Remember, UJ row represents int pointer. So it's pointing to a specific row, right? What I could do is I could do this. I could dereference and say UJ row and then access, and then access, right? Or I could just, I think I can just do this. No, will this work? No, I don't think so. I don't think that'll work. Yeah. So let's try to understand the UJ row class, right? So we have this, we need to use this operator over here. So I think I need to dereference in order to use it. Yeah, I think I need to dereference in order to use it. So let me try doing that. So I'm gonna dereference, then let's see if that's gonna make, let me see. Expected type specifier. Or maybe I need to make it, I need to use, yeah, I think I need to make two, I need to make it a pointer like this. So for it to be pointer, pointer, but then no, that would be wrong if I make it pointer, pointer. Yeah, that would definitely be wrong if I make it a pointer, pointer. So it's good if it, okay, let's see if it pointer, pointer, nah, yeah, it's going to be wrong. Okay, seems to be working, but technically it's not. So what I need to do is oh, so I think I need to do it this way. I think if I remember very well, you need to dereference like this, if I'm not mistaken. Yeah, you need to keep dereferencing. So yeah, if I'm not mistaken, yeah, I think this should be, but then it should be what it should have technically should have been one pointer. I think I'm missing something here. The thing is, this information is not on the slides. So let's go back here and double check. So if I use UJ row, yeah, okay, I think maybe this is fine. UJ row and then that, and then indexing. Oh wait, or maybe I need to use the constructor. Let me think about it. I could use the constructor, the rows that takes in the rows to initialize that because it's a, yeah. I think it should actually be like this one pointer that points to a row, right, which is fine. And then each of the rows, yeah, each of the rows points. Let me see if I do this over here. Okay, this section here, it works perfectly fine. I'm not sure which part should I call the constructor. Should I call the constructor here like this or what? Let's see if, okay, it does work. So I've initialized the UJ row, right, to my rows because like I said, it should represent the rows. So here I use the destructor to initialize the rows, right? Since the rows are represented by UJ row. And then now I need to allocate the columns, right? So to allocate the columns, if I'm not mistaken, I think I can do this. I'm not sure if this will make sense. I'm not entirely sure if that's gonna make sense. If I do this, I'm just trying to check something. Okay, it's not gonna make sense. So after saying new, or maybe I start allocating the pointer on the outside and then I use angle brackets here. Let me see. I can't, I think I totally forgot here how to implement it. The problem is they didn't put it in the textbook nor the slides. So it's tricky to figure out. Let me just see something here. So here I can point to the pixels array, which is that row, dereference that row in that specific row, and then call that column. Okay, yeah, it's not really a problem. Then we also need to change things up a bit down there. It's going to become more and more cryptic. So Let me see if I do this. Okay, that's not the case. So I need to say new here. Okay, I think here should be new int. So let me see. If I say new int, not it's of type UJ row. This is tricky. But then I think, yeah, I think so. I think I can do it this way. Let me try doing that. Let me say UJ row. In that specific row dereference. Let me see if now it's gonna work. Okay, it still doesn't want to work because I just wanted to like access the row for the UJ row every time, right? At that specific index, and then allocate that underscore columns. Make it the size of columns. So it says expected specifier type before the pointer. Okay, yeah, it expected a specifier type, so which is UJ row. So this is not going to work. I don't know. This is the only part that I forgot. I don't know what exactly how to access the row. So let me just think about it for a second. Let's see. To access the row, it has a constructor, right? It has a constructor class, which is this, and you can call the operator there, right? But then to call the operator, you have to dereference. You have to point to that memory location. So new is equals to that row, those rows. Okay, this invalid conversion from UJ row pointer to UJ row const reference. Or maybe dereference after. Okay, nope. It doesn't want to dereference. Where should I dereference? Or should I make UJ row pointer pointer? But then no, that would be incorrect. This is the actual way it's supposed to be. So let's see. UJ row candidate is, and then near match. Oh, okay. I think I see my mistake. I think it should be an int there. Okay, that's still not it. Uh, d- 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 mm, okay, let me check something here. They're supposed to. So you allocate UJ row, right? And then you pass those rows, which is not a problem. And then, okay, or maybe it needs me to do that here. Yeah, so let me do that here. Let me say dereference and see if that's going to work. And then uj row. Okay, still. So new. Just this one error. So I'm not, but it has to be one that I know. It has to be there has to be one pointer because uj row already represents one of the dimensions. So this is fine. So now the question is, how do I allocate that? So let me try to read it properly. So at every single index, right, it's going to be uj row, which is just, oh no. Okay, the outermost pointer represents the rows, right? I don't know whether it's called uj row or uj but then either way, it's fine, whatever you call it. So it's going to be this, and that's so basically we treat this as like a one-dimensional array of type uj row. So that means I'm going to start by allocating the outermost one. So let's start by doing that. So start by allocating the outermost one, which is the pointer, right? So uj row pointer allocated that. And then now at every single index, oh yeah, I think at every single index, now I need to say new uj row, calling the constructor. When passing, okay, I think it should actually be called uj column. I think so, because at every single position, at every single index, it's a uj row. So I need to instantiate it, passing it the size. So I don't know why it's refusing now to work. So failed to convert from uj row to const uj row by reference. Which const uj reference here? Is it this one? Yeah, this should be fine now because I understand it now. It should be fine. So at every single index, it's a uj row, one dimensional, right? But then uj row is another dimension. So yeah, we need to also allocate that. So we allocate that by calling the constructor. This should have been fine. This should have worked perfectly fine. Mm. Oh, but then it's fine. I don't know why it is complaining. It is fine. I don't need the pointer. It is fine. I'm not sure why it's the issue now. And then a new uj row. So the operator pointer of type no match for operator pointer of type uj row. But then at every single position, okay, I think this is okay. Now that's fine. At every single row, it's going to point to, yeah, this should have worked perfectly fine. I'm not sure about this operator. Now I'm not sure, but then let's this is just the one line that's affecting everything. So let's just do this here, fix the other lines. So remember the uj row is a row, right? So I need to point to that row first. After pointing to that row, and then I index, I pass in the column. And then I pretty much do the same thing there. So I need to point to that Okay, let me just fix the other errors for now. Okay, this still is giving me an error. Why though? Because I indexed the right way. Left operand of assignment, blah blah blah. But then it is fine though, because I didn't put a const here, so that's fine. It should allow me to update this value since this is of type UJ ppm. Okay, this is taking way too longer time. I'll have to come back to that. So let's go to the last one. But then the last one is not too bad. The stream insertion operator, because now it's wasting my time. I forgot how to implement it. So to overload the stream insertion operator, right? You'd have to overload it as a friend function. Why? Because remember when you see out, let me show you. When you say see out, okay, let's just put it this way. Let's just say these are the only ones. You have see out and then you have the object, right? What this means is that on the left, the left operand is of type O stream. See out is of type O stream. And then the right operand is of type string, right? Of type string. Why? Because the 2PGM function returns string. So the left operand is of type O string and then the right operand is of type string. So that's what it means. So as remember the rule, the left operand needs to be of type UJPPM or the name of the class in order for it to be a member function. In this case, it's of type ostream. So therefore, we have to make it a friend function. It still has access to the private member variables. Don't forget that. So I'm going to come here and make it a friend function. So friend functions, since they're not part of the class, you always put them at the top there. It's up to you. You could make it here as public, whatever, but then you always put them at the top. Before anything, you always put them at the top, all friend functions. So to overload, I'm going to say I want to overload the operator, the stream insertion, which takes in an O stream, but then it's part of the standard namespace, something of O stream type by reference, right? Because we don't want to take physical objects. It's going to make the application slow. So by reference, I'm going to call it O left hand side for my left hand side. And then it takes in a const uj ppm by reference obj right hand side, right? So this would be the function. But then remember, when you implement it, you implement it without the friend keyword. So, and what should it return? I forgot to put a return type. It should return an O stream object by reference. That's the syntax. And then I'm gonna copy all of it. The UJPPM I still need to fix the thing, that other one I need to still figure it out. I'm not sure what's the issue. And remember what he said, when you're implementing it, you omit the friend keyword. And then did I say using namespace standard? Yeah, I did. So you can remove the standard, the STDs, you can remove them. So now I'm going to output, right? Which is basically like I said, that this code is the same as the string stream. It's basically this code here. The only difference is that I'm no longer using the string stream, I'm using the output string, which is the O string. So all occurrences of string stream should be replaced with O left hand side. So copy this and then replace that, and then replace this, and then remember I shouldn't return O stream. I shouldn't return the string anymore because it's an operator. I should return the O string, and then it's going to take the address, go to the address of that O string. So that's why I return OLHS. And then what else? Okay, yeah. I need to say obj right hand side, it's rows and columns. So dot calls dot rows and then dot rows dot calls. And the pixel is from the object, so object dot rows like that. Okay, I think as the syntax, yeah, the syntax now changes because this is when I say dot, right, it's gonna point to this address, right, or this UJ row. It's gonna point to this UJ row. So that UJ row that it points to, I need to dereference it. So I think this should be the right syntax. I dereference it, and then after getting that UJ row, I index into the column. So build. Why is this one complaining now? Okay, it's going back to the top. Let me see if there's any other places where it's complaining. Okay, it's complaining about that. So I need to delete. Let me see. So now, okay, the code is changed. It's no longer UJ pixels, now UJ pixels. But then it's fine. We'll fix that now. So the code for outputting, I'll try to fix the errors now. So this code, the ostream operator there is exactly the same as the two ppm or two pgm function. Then now I'm going to go this side. Okay, so now I can use this instead of calling the two pgm function. Now I can just say cout obj1, and then it's going to output that object. So here I'm invoking the operator, the stream insertion operator. So let's try to figure out this thing. So at every single row, at every single position, it's a UJ row, which is fine. Yeah, I think this is fine. There's just something small that I'm missing, but then I know it's fine. This will be UJ row. Or maybe it should be 2 pointers. I think, not sure, but then let's try that. Let's make it 2 pointers and see if we can get away with that. So build and run. Okay, this is missing a pointer there. Yeah, pointer there, and then replace this with that, and then at every single, okay, this is not going to work the way I intended to work. I think I understand the issue with the, but then it's fine. But then I think I can understand the issue with this line here. Okay, I think it has to be 1 point because it wouldn't make any sense for me to say 2 when one of them should represent. It's sort of like a, yeah, if you remember type def, right? This UJ row class, you can sort of like think of it as like we've named a type, right? This is type definition. So it's pretty much similar to that. So this can call this operator, then it's gonna return an integer. Yeah, it should return an integer. Or maybe I didn't implement the operator properly. But then I think it's fine because it should return an integer, which should be that pixel row, right? Which is fine. And then okay, this should now take in the column, and then it returns an int because, yeah, should I say UJ row now? Nah, I don't think I should say UJ row. So let me check that operator. Did I implement it? Oh, I didn't implement that single indexing operator. So let's start there. I don't know what I just forgot to implement it. So let me copy it, then go to my CPP, and then it's part of the class. So I need to use the scope resolution, and then to return, I'm gonna say return underscore pixels in that specific row or that specific row, right? Dereference, and then that specific column. But then it's supposed to allow me to take two parameters. I don't know why it's doing that. It's supposed to allow me to take two parameters because I need to be able to get the row and the column. Yeah, something is not right here. And it's a small thing. I just can't figure out what's the small issue because pixels needs to take in a row here, and this function is not allowing me to take multiple parameters. Mm, duh, 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 duh. The other one is easier. That's why I don't like this one. You see this one, it's very easy. Just taking a row and a column, and then you return. That's it. Very straightforward. This one over here, it's a bit tricky. As you can see, it's giving me problems here. So, okay, this shouldn't be there anymore. So I allocate for the outermost pointer, right? Which is fine. And then once I'm done, I can do this. But then I need to call the constructor and pass the actual size. In this case, I should have actually called UJ call, but then it's fine. And then, yeah, everything should, from my perspective, everything looks fine. Now everything looks fine. Why do I say so? Because at every single index or that pointer, every single index, it's a UJ row, right? It's a UJ row. And then at that pointer, we need to allocate it first. Once you've allocated it, then we can use that means that every single index, when I put in an index, which is R in this case, it should return a UJ row. So I need to instantiate that UJ row to that on the heap, which is exactly what I'm doing. Build and run undefined. So undefined convention from JPointer to const UJ row. Oh yeah, this is a pointer. Okay, this returns a pointer. This returns an address, right? And then it's saying this one is this is a const reference. I'm not sure what the issue is. I guess I have to go through it and try to figure out what's the issue. I'll just upload this code as it is, and then when I figure out what's the issue here, I'm not pretty sure what's this. It's a small issue that I'm pretty sure there's a small issue here. It's not a big thing. So just be patient. I might have to upload another video after this one because I'm not sure why it's not working here. Because I did follow everything. This is a UJ row, whatever, instantiated, call the constructor, everything is fine, but then it says this is a const reference and then this is a pointer. They're different. Oh, okay, I think I might have an idea. Let me try this. Might. It's just an assumption. I might. So make it pointer, pointer, right? And then pointer like this. And then let me build. Yeah, seems like that works now. So I think I think it wants you to use 2 pointers because I was pretty sure this would work. So now we have 2 pointers, and then we can just dereference that. You don't have to, I think you don't have to dereference. So you can just do this to dereference to get that pointer, right? That UJ row in that specific index, and then use the column to get it. So let me see if, okay, that's, okay, it crashes when I do that. Okay, so let me build again. Yeah, that's the thing. I don't know why this operator is refusing to take into 2 parameters, because I was supposed to take in a row and a column, despite it being like that. It's supposed to take in a row and a column. Must have exactly one argument. Yeah, this is the problem when they don't put information on the slides or in the textbook. This information is not even in the textbook. I don't know how they expect you to understand. So yeah, I'll just continue in the next video.